Data pipelines are the backbone of modern data architectures, enabling the efficient flow of data from various sources to their respective destination. So today we will delve into the basics of data pipeline, discussing their architecture, benefits, and real-world use cases. So let's get started with what is data pipeline. So basically, this data pipeline is a series of steps that moves data from its source to its destination, where it can be processed, transformed, and analyzed. So basically, it is a sequence of automated processes that allows the data to flow seamlessly from one system to another, enabling efficient data management and analysis. So think it like a water pipeline where the water flows through the pipes undergoing various processes, example filtering, heating and distribution before reaching its final destination. So similarly, data flows through a pipeline undergoing various transformation, be it cleaning, processing and analyzing before reaching its final destination for storage, visualization or use in machine learning models. So this data pipeline is essential for handling large volumes of data generated by various sources such as sensors, social media platforms, databases, and software applications. It ensures that data is available for analysis and helps organizations make data-driven procedures. Then comes architecture of data pipeline. Now in the data pipeline, data flows from various sources through the series of stages, ultimately landing in a target system. So its architecture consists of three main components. First is the ingestion, which is the main step in the pipeline where data is collected from various sources such as databases, APIs, files, or real-time events. So this ingestion involves extracting the data, transforming it if needed, and preparing it for further processing. Then we have processing stage, which involves analyzing, cleaning, and transforming the data into a format suitable for downstream system, and which may include tasks like data validation, aggregation, filtering, or enriching data with additional information. And then we have storage and delivery stage, where data is loaded into the target system. Now here the data may also be distributed to other systems such as business intelligence tools for analysis and visualization. So this simple architecture forms the core of data pipeline, ensuring that data flows smoothly from various sources to its intended destination, enabling data-driven decision processing. Now the question arises, how to design a data pipeline? So basically, designing a data pipeline involves defining a series of steps that transform the data, move the data from its source to destination. So here first we define the data sources, where we identify the data sources we'll be working with, such as databases, APIs, files, or web scraping tools. So for example, a social media platform's API could be a data source for collecting user data. Then we determine the data types and the volumes. So here we identify the types and the volumes of data we'll be handling, which helps us choose the appropriate data processing tools and storage solutions. For example, if we are collecting tweets, then we'll need to process large volumes of text data. Then we choose the data processing tools, where we select the tools that can process, clean and transform the data. And these tools could be ETL, that is extract, transform, load frameworks, data processing libraries, or data integration platforms. For example, Apache Airflow, Apache Niffy, or DBT could be used as data processing tools. Then we set up the data storage solutions, where we choose the storage solutions that can handle the data volumes and types, which could include databases, data warehouses, or data lakes. For example, Amazon S3, Google Cloud Storage, or Snowflake can be used for data storage solutions. Then we design the data flow, where we define the sequence of steps that will process and move the data from its source to destination, and this may involve tasks like data extraction, transformation, validation and loading. For example, data is extracted from social media API, transformed it to fit the desired schema, validated for quality, and then loaded to data warehouse. And finally, we implement and test the pipeline, where we set up the pipeline using the chosen tools, test the pipeline using sample data, and verify that it is functioning as expected. For example, here we can use Apache Niffy to extract the data from social media API, validate the data, and load it to the Snowflake data warehouse. And finally, we monitor and maintain the pipeline, where we regularly monitor the pipeline to ensure that it continues to function as intended and troubleshoot any issues that arise. For example, we can set up alerting mechanism to notify if data occurs or data error occurs, or schedule regular maintenance tasks to optimize the pipeline performance. So by using these steps, you'll be able to create an effective data pipeline that efficiently processes and moves the data from various sources to its destination, where it can be utilized for analysis and decision making. Then comes ETL versus data pipeline. Now this extract, transform, load and data pipeline are related concepts, for they serve similar purpose, and they both handle the flow of data from its source to destination, but there are some differences in them. First is the ETL, which is a set of data processing tasks that involves extract data from various sources, say databases, APIs or files, then transform data into consistent format, clean it, apply business logic, and then load the transformed data to target system. Whereas on the other hand, this data pipeline encompasses a broader range of steps that go beyond just extract, transform, load. So these data pipelines are typically designed to handle the complete life cycle of data, including data ingestion, processing, storage and analysis. And they often involve additional steps like data validation, data quality checks and handling. So to summarize this, we can say that this ETL is a set of tasks within a data pipeline that focuses on extracting, transforming and loading data. Whereas this data pipeline is more comprehensive framework that encompasses ETL and additional steps involved in moving and processing data from various sources to a final destination. So let's understand data pipeline better using a Python code. So let's take a general example where we are considering a simple data pipeline that fetches data from REST API, transform it and stores it in a local CSV file. So first of all, we will install the required packages. Then we'll create a Python script, say data pipeline.py with this code. And this code fetches data from the API using the request library, transform the data using pandas library and store it in a local CSV file. So here you can replace this API example.com with the actual API endpoints and modify the parameters according to your use cases. So basically this is a simple example, and in a real world scenario you would likely use additional tools and techniques for error handling, scheduling and monitoring the pipeline. Thank you.